Hey everyone, thanks for joining us for our next episode of our AKS series. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter to answer. Our session is being recorded. It will be available to view on demand within 24 to 48 hours. With that, I'd love to turn it over to our host for today. Paul, thanks so much for joining us.
Hey, everybody. Welcome back. I'm so glad to be back on this series. I think this is the 7th or 8th episode. I'm pretty sure this is the 8th episode. Yeah. But I'm back. I was here for the first two. And then we had Diego previously. He did some pretty awesome work with Istio Service Mesh and observability. And then we also had Steve Griffith do a session on event-driven workloads on AKS. And so I am back for the remaining two episodes. Today we're going to be talking all about deploying AKS with Terraform and Azure Verified Modules. So yeah, I'm happy to be here. These are my two favorite topics, technical topics, AKS and Terraform. So let's go. This is pretty much the only slide I have for today. The only other thing that we're going to be doing is diving right into the workshop. So let's just hop right over to it. So as we dive in, I'm going to drop this into the chat window here. Everybody, if you want to follow along at home. And by the way, this is recorded and actually streamed to the Microsoft Reactor channel, which you're probably on. And it's also streaming to the AKS community channel as well. So these recordings, you'll be able to find them in either place. So what I'm going to do is I'm actually going to just drop in a URL so that you can head over to this link here. Now, let me click it just to make sure it works. Yep, it works. Okay. So when you land on this page, this is the landing page for AKS Labs. This is where you can find pretty much a ton of different lab content as it pertains to AKS. So what you want to do is you want to basically just click this link at the top here for the workshops. And today, what we're going to be doing is we're going to be exploring the operations section. And within there, we have this lab over here, which was just recently published. So if you just click on the deploy AKS clusters with Terraform, you'll be on this page here. And let me just scoot this over. By the way, if the left navigation content gets in the way, just click this little button and kind of scoot it to the side. So we'll do that. Scoot it over to the side. This prerequisites section should include all the information that you need to go ahead and get started. So the objectives for today is understand what Terraform is. I don't know how many folks are actually on the stream right now. We have a fairly decent number of you. Post in the comments here how many of you are already using Terraform. If you're already using it, give us a thumbs up. If you're not using Terraform yet, but you're curious to get started, give us a smiley emoji. I just want to know like where folks are at. Regardless of the situation, in this session, we're gonna, you're gonna have a solid understanding of what Terraform is, know the basics and how to set it up on your machine. And then we're gonna configure this thing called remote state. And I'll show you what that is in just a second. And then we'll actually deploy an AKS cluster with an Azure Container Registry. And then we'll understand a little bit about the AZ API provider, okay? So yes, there is a poll. I see in the comments here. Thank you, Anna, for that. Anna is our lovely producer for this call. Click that vote button. See, I want to know what you know about Terraform. Okay. So to get started, what do you need? Pretty much for all AKS labs, you're going to need a subscription, and you may need a GitHub account. You don't quite need one here, but you definitely do need an Azure subscription, and an Azure subscription with enough quota to deploy AKS clusters. Okay. You should also have Visual Studio Code. That's not mandatory for Terraform, but it's super handy, and I'll show you at the end. You definitely do need Azure CLI for authentication, especially when we're like working locally within our dev environment. Having Azure CLI is super handy. And then, of course, obviously, Terraform CLI. So we'll go ahead and set that up. So let's just dive right in. Assuming that you have Azure CLI installed, what you do need to do is you need to log in first and foremost. Okay. I've already done that, and I'll show you. Boom, 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 boom. Let's go over here. So AZ login. I'm going to log in using a special tenant that I have for my test subscriptions. Should be good there. Retrieve subscriptions. Okay, and then here you're gonna have to basically select what subscription you want, and I'll type in the number for my subscription. This is only presented to you when you have access to multiple subscriptions, and so I do, and so I needed to select that. The next thing we want to do, sorry for all the jumping here, is you want to include, and this goes for all AKS labs here. You want to install the preview extension for AKS. Not quite necessarily needed for this particular lab, but it's just good practice, especially when you're working with these AKS labs. Okay. So let's just dive right into this. What is Terraform? Okay. So Terraform is basically an infrastructure as code tool created by friends at HashiCorp. And it basically enables you to define your cloud infrastructure using what's known as the declarative approach, right? So it's infrastructure as code. All cloud providers, Kubernetes in general, they're all backed by APIs, and therefore you can actually submit code to these API servers, and it'll actually provision infrastructure for you. The old way of doing it, which is, I wouldn't say it's the old way, it's a way of doing it, is using ClickOps, right? So I can hop over to the Azure portal, right? I can say create, I can create a resource group, an AKS cluster, and all that stuff. But you're pointing and clicking, and it's not very scalable. So when you get to the point where you need to provision infrastructure at high scale, you're going to want to do that using code. Okay. Now, when it comes to provisioning infrastructure using code, there's two approaches for that. Okay. The first approach is going to be taking an imperative approach. This is like when you're using Azure CLI, and AKS Labs does this all the time. I mean, we do a lot of this stuff. So if you are, I don't know, I'm just going to hop over to one just to kind of show you what I mean by that is here. This is what's considered an imperative approach to provisioning infrastructure. You write code, yes, it's infrastructure as code, but you're basically telling the API server exactly what to do. So create the resource group, create the AKS cluster, create a storage account if you want. And you literally have to give it step-by-step, line by line, what to do, right? With Terraform or with taking a declarative approach, you don't need to do that. You basically define what you want that end state to look like, and then whatever that tool is, we'll go ahead and provision that for you. So all you're saying is, I want a resource group in this region. I want an AKS cluster that has these certain properties. And then Terraform is going to go and do the magic, right? And there are other tools as well. There are other infrastructure as code tools like Azure Bicep. So if you are an Azure customer and you only focus on Azure resources, Azure Bicep is probably one thing that you want to kind of lean towards. But if you are a multi-cloud customer and you want to use a tool that basically for any cloud, right? You could use this because Terraform has this concept of providers that allow you to deploy into any cloud, which is pretty cool, right? So with that said, let's go ahead and run through some Terraform basics, okay? So first thing you need to do is you should head over to the Terraform website, HashiCorp website, and there are instructions here on how to install Terraform, and you can install it on any operating system you have, right? So I'm on a Mac, and it just defaults to this Mac. If you have Windows, there are instructions here for Windows. If you're on a Linux machine, there are instructions for all the different flavors of Linux as well, okay? So with Terraform installed, what I would recommend is that you install VS Code, and here's why, okay? So if you don't already have VS Code, head over to code.visualstudio.com, and again, you can basically download for any operating system, and once you have VS Code installed, let me flip over to my VS Code. This way. Okay. VS Code, you might know this, supports a bunch of extensions, right? And so what I can do is I can look up Terraform. Okay. Install this, the HashiCorp Terraform. And this is great because it does syntax highlighting. So I'll go ahead and install that. And then we're also going to play with some AI because we cannot avoid AI. We have to, we got to lean on these tools whenever we can. So GitHub Copilot, I recommend that extension. And then I also recommend the GitHub Copilot chat extension too. We're actually going to use that in this lab and it's going to be super handy. Okay. So once you have all these tools installed on your machine, so I can say like which Terraform, yep, Terraform is here. Terraform version, yep, I'm on 112, which is a fairly recent one. We can actually start to dive in and start building, right? When you write your Terraform scripts, you basically write them in a language that's called HCL or HashiCorp configuration language. This is what's known as, it's not a real programming language, it's a domain specific language where you can actually write your configuration in a way that Terraform knows how to interpret. Okay. So what does that look like? Well, that kind of looks like this here in this example. Okay. The first part here, this is what's known as like the resource type that you're going to deploy. And in this particular example, it's going to be an Azure resource group. This second bit here, this is going to be like the name of the instance of this type, right? And this is primarily used for state. This is not, shouldn't be mistaken for the actual resource group name because the actual resource group name is actually plugged into a property, right? Called name. And then the actual location is another property, right? So in the Azure, on the Azure side, once you deploy this, you're not going to have a resource group of the name example. It's going to be this big long one here, which is example resource group. Okay. And so again, this is primarily used for identification within the whole state file because Terraform relies on that. And we'll talk a little bit about that. So what we can do is we can actually start to build together. And before we do, there are some basic commands that you should be aware of. And if I just jump this way, so I can just type Terraform, and it'll show you all the different commands that are available to you. The init is what we're going to be running. You definitely need to do that as you build out your modules. Validate is a great way to do very simple linting of your Terraform code. This will basically allow you to make sure that your syntax is properly written. And then, of course, we have plan, which is going to plan out your infrastructure deployment. We're going to apply it and then destroy it if we need to. We're definitely going to be destroying at the end of this lab, because I don't want this stuff to be running 24/7. Okay, so those are just the basic commands there. Now let's go back here and let's start working with Terraform and Azure. But before I do that, I see some things in the chat here. Let's just make sure that I address some of these questions. And yes, feel free, if you have any questions along the way, post them in the chat, and I'll try to get to those. Okay, so I see Coach V joining from ATL. Nice, ATL. KubeCon is in ATL this November, so I will be going there in November, hopefully. Okay, so do you have a fix for Azure Management API connectivity failure? I don't know what that is. API connectivity failure. Connection may have been reset. I do know that sometimes when your Terraform CLI actually tries to talk to the Azure Management APIs, or ARM, there might be some slight hiccups, because there's constant communication going between your machine, or whatever machine Terraform is running on, and Azure. So just make sure that your network connections are pretty solid. Other than that, I haven't really run into those in a very, very long time. Okay. Aquarius 123, hello from England. Awesome. England is awesome. I love it. Okay. Terraform apply, making it impossible to complete. Nor cleanup or with the destroy. I haven't seen that quite yet, but if we encounter it, we'll be able to troubleshoot here on the spot. Okay. Okay. So other than that, did you add HashiCorp Terraform extension or Microsoft Terraform? Great question. I added the HashiCorp Terraform extension. Okay. All right. So let's go ahead and get started here. What I'm going to do first is, and let's just hide that and maximize my terminal. First thing you need to do is you need to tell Terraform what subscription it can work with, okay? And you can do that by, number one, logging in to Azure CLI, and then you need to export a value, okay? And so here, I am basically doing the AZ account show and grabbing my subscription ID, and then passing that into this environment variable called ARM subscription ID. And that's actually documented in the HashiCorp docs for Azure. So we just need that, okay? Now, what we can do is we'll create a working directory where we're going to put some code files into, okay? And so here, what I'm going to do is I'm working out of my TMP directory, because I don't want this stuff to lay around afterwards. And so I'm just creating a new folder called AKS Terraform. I'm going to change directory into there, so CD, and then I'm going to create a new file called main.tf, okay? And so if I just click that, and then if I pop over here, oops, let's open this in code. So it should open, not quite what I wanted. Hold on a second. I will close that. Close that. Let's do this. Let's open folder. let's do this. Hold on a second. MacBook. It's probably not going to find my TMP. No, it's not. It's not. Hold on a second. I'll do this again. Okay. And let me switch the profile so you guys can see a little bit better. There we go. And we'll do that. Okay. So now I have a single file in my working directory. And because I'm in a new terminal, okay, I need to export my subscription ID because sometimes that stuff doesn't persist between terminal switches. Okay. So I have a blank main TF file. What can we start doing? Well, we need to start setting up the actual providers because Terraform is, again, a tool that allows you to work with any cloud provider. And so if you hop over to the Terraform registry documentation, and if you click on providers, you'll see that there's a provider for all the major clouds, okay? And so we're going to be working with Azure over here. So if I jump over to the Azure RM provider, you can see a couple things here, okay? You can see all the different versions of the provider, okay? So we're on 438.1. You can also click here, which is documentation, and then you can see that this is like the official guide on how to use this particular provider. And you can see here, authentication. This can be done in many different ways. And in our particular scenario, we're going to be using the Azure CLI for authentication. So if I click on the Azure CLI, it has all the different instructions on how to do that, right? So we've done all this stuff. So let's just make sure. And these docs are like a gold mine of information. So I always bookmark the docs here because I'm always referring to it. So the first thing that you need to do is you need to tell Terraform which provider that you're using, okay? And so if I head over to my VS Code, and let's collapse that a little bit. So what I'm doing in main.tf is I have a Terraform block, and the blocks are kind of like wrapped in these curly braces. I'm telling it which provider I am using. I'm using the Azure RM provider, and I can specify a version. This is good practice. You kind of want to pin to a specific version, or you can use this little tilde arrow operator. This is more of like a pessimistic constraint that you can put on these dependencies. And basically what I'm saying in here is use 438 at minimum. And because of this little tilde arrow operator, it can bump any patch versions automatically, right? And I'll show you that. So one thing I need to do as well is some providers work a little bit differently. For Azure specifically, you need to include features, feature settings for your provider. And this features, you could just have an empty block, but the one thing that I like to do is, because I'm building demos all the time, I like to set this particular feature to false. Basically, this is saying prevent deletion if contains resources. So let's say you use Terraform to deploy a resource group, and then you use Terraform to deploy, let's say, like an AKS cluster. What if somebody goes in and deploys a storage account in there? Well, Terraform could stop and say, hey, wait. There's a storage account in here that I'm not aware of, but I do see a storage account. I'm going to prevent any deletion of resources, right? So that's actually a good thing. But in my scenario, I don't really care. This is just a demo environment. I want to trash it. And so that's why I set this to false. Okay. So I am going to add that to the bottom here, and we should be good to go. And so that's basically all you need to do to work with the Azure RM provider. So this right here will get us all set up. Now, what I need to do is basically run a Terraform init command, okay? And what that will do is it'll actually go out to the HashiCorp Terraform registry and download the provider for me. Okay. And did you notice here? I mean, I wanted 438. It knew that there was 438.1 available, and so it just automatically bumped it up. So using this little tilde arrow operator is a pretty good practice, I would say. This ensures that I am going to stay on 438 version of the Azure RM provider, but I can have any of the security patches if there are any. Okay, so providers all set up, we're good to go. All we need to do now is basically start deploying resources. Okay, and remember how I said this documentation is a gold mine? Well, it's because they actually document every single Azure resource that's out there. Okay, so anything you wanted to work with, you can basically find it, right? So I don't know, let's say container, right? Container is what we want to deploy. There is Kubernetes cluster, right? And so you just come out to the documentation. Oh, and you can filter too. So if you're like, if you kind of know the name of the resource that you want to deploy, you can do that. And so you can actually just click on the actual resource. They have example code in here. And then for something like AKS, there's a lot of properties that you can set. Okay. But in our case, we want to start small, and then we want to build upon that. So I'll just copy the resource group code from the lab guide. And this is the exact same example that we were just looking at. Okay. So we're going to deploy this Azure RM resource group. We're going to name this particular instance example, but the name in Azure is actually going to be example resource group. Okay. And for the location here, I am going to change this to a region where I know it's going to work, because I'm on a brand new subscription that doesn't quite have all the quota that I need. So I know this works. Okay. So whenever you add something like that, oops. Okay. So you can see here, these are hard-coded values, right? And so if I wanted to use this template somewhere else in a different region, what do I got to do? Well, I got to change the name of this, okay? Which is fine, but we don't want to do that all the time. What we want to do is we want to use variables, okay? And with variables, what you can start to do is you can actually define variable names, right? So in this case, I want a resource group name variable, and then I want a location so that I can pass in whatever I want. And then you can be descriptive about it. You can have default values for it. You can set the data type, right? And so this is a pretty good way to make sure that your Terraform is reusable, right? And so what I can do is I can just create a new file, and it doesn't need to be a new file, but it's always better to organize your Terraform files in such a way, right? So here I have a variable named resource group and a location, and I'm actually going to change this again to Austria East, okay? So I just declared the variables, but I'm not using it just yet, okay? And so what I can do is I can hop over here to my hard-coded examples, and you see this here? The syntax highlighting, the IntelliSense. I mean, all that is available because I have the Terraform extension installed in VS Code. So it's pretty handy, and it makes it very easy to use, right? And so that's pretty much it. So we have variables going in. We have the main file that's actually going to do the work. Usually want something coming out on the other end of it. And in this case, I want to output of the resource group name. Okay. And so what I can do here is I can also drop in a new file called outputs.tf, copy that, paste it in. And so here, I want to output the resource group name, and then check this out. Azure resource group dot example dot name. Okay. So this is how we're going to identify that one particular resource. Okay. And so think of it like this: Azure resource group dot example dot name, because name is a property of this particular resource. So that's the convention there. Okay. So we've written Terraform that can deploy a resource group. Not a whole lot of fun, but we have to take baby steps, and we have to make sure all this is working, and then we start to build on it, right? So what I'll do is, because I have a new provider, did I init it? I think I did. Let's just do this one more time. Okay, yep. That went really fast, so I didn't need to do that. So now what I can do is, let's go ahead and make this a little bit bigger. Terraform plan. Okay. So now I could run a Terraform plan, and it's going to take a look at the configuration, basically do a what if, right? What if I want to deploy this into my subscription is basically what it's saying. Okay. So Terraform plan, that just kind of flew by really fast. But basically it says Terraform will perform the following actions, right? And it's going to deploy one thing, resource group, and it's going to output the resource group name. Okay. But then it says, hey, you didn't provide the out option. That's probably a good practice, right? So I can out, which basically says redirect. So basically create a plan file and then save it to a plan file like on my local machine. And so you can actually do that, which is probably a best practice. That way, when you want to run Terraform apply, the apply doesn't have to do the planning again. It can just basically refer to the plan that you output, right? And so now if I want to do Terraform plan apply from the plan, and the plan, by the way, is just a binary file that Terraform knows how to parse through. If you try to open it, it's going to look like gobbledygook. Okay. So we can actually run the Terraform apply from the specific plan. Okay. So remember, Terraform plan to plan out your infrastructure deployment, Terraform apply to actually go and apply that to your subscription. Okay. So it's working. It's doing its thing. It's creating. This should be really fast. Yeah. Resource groups there. You can create that in a few seconds. So you can see here that the apply is complete. One resource is added. And that's what we have. We have the resource group name. Okay. So there we go. We just deployed a resource group. Now, if I were to say, did it really create? I can go to the Azure portal, or I could run this command, this AZ-CLI command, basically saying, hey, go show me my resource group with this particular name, because that's the name, right? It matches. And so this is coming back from Azure CLI. And so I believe that Terraform deployed into my subscription. Okay. Now, next thing we want to talk about is state management. Okay. Because I didn't do anything with state yet. What do I mean by state? So Terraform has this thing where it actually tracks all the resources that it provisions within its own state file. This could be a good thing, could be a bad thing. I know a lot of folks are a little indifferent about this. With Azure Bicep, there is no state. The resources in Azure is the state, but in Terraform, there is state. Okay. And so if you notice here, there was a file that has been created that I did not create. Terraform created this. Okay. And it's called the Terraform TF's state file. Within the state file, you can see that if I click on it, it opens up in my VS Code. It's all human readable. It's all JSON. And there's a lot of information within this state file. One huge warning here. This can contain sensitive attributes. Okay. And so this is the reason why it is extremely important to handle these, and I don't know what that is. Okay, that just popped up and went away. I'm not sure if you saw that, but you want to make sure that you are handling these state files with great care. Okay. In my example here, it's just a file sitting on my local computer. Okay, which is fine if I'm the only one working on my infrastructure, right? But if you're working in a team, you generally want to put this in some sort of remote storage. Okay, and there are a few options for that. You can actually store it in HashiCorp's service. So they have a cloud service called HCP Terraform. If you create an account with them, you can actually configure your main TF or your Terraform block to say, hey, use my HashiCorp Terraform account, and it'll keep all that state information, so that TF state file won't be on your local machine. It'll actually be up in HashiCorp's cloud, and they'll manage all that for you. The other option is to actually use Azure Storage. And so we can actually use Azure Blob Storage and keep our files over there. And that's what we're going to do in this example. Okay. So what I'm going to do is I'm actually going to copy this particular command. And let's do this, create the storage account. I just realized it's in a different region. You know what? I think that's okay. We're just demoing this right now. Ideally, you want it in a region. Actually, no. You know what? The regions don't really matter. It matters on where your Terraform is being run from. Okay. Okay. So what I'll do is storage accounts, if you've created them in Azure before, they need to be globally unique. And so this is a command that I'm using to make sure that it is globally unique. And then what I'll do is I'll create the storage account. And then I will create the blob container to actually store the files. Okay. So this should take a second to complete. Come on, there we go. And then I will create the storage container. Okay, so now we are all good, but we need to configure the Terraform to now tell it, use this backend for remote state. Okay, so what I'll do is I'll go back up into my Terraform here, and underneath the required parameters, I can drop this in and I can say use Azure for my backend state. The resource group, that is the name of the resource group. Storage account name, that's just a placeholder. I need to actually get the storage account name because it's a really long and unique name. So I will paste that in here. The container name, this is the name of the blob container that I created. And this is going to be the name of the TF state file. So what was over here in my local directory is now going to be over in my blob account. Okay, so I will save that. Now, here's one cool thing that you should always be doing. Notice how when I just copied this in, the indentation is a little weird. You could fix that manually, but you don't have to. What you should be doing is running a Terraform FMT command. Hold on a second. I need to save it before. Okay, we'll save it. I could run the FMT command one more time. And you can see here that it actually formatted all this stuff for me because HCL or the Terraform language, it likes to be formatted in a nice, clean way, right? And so you don't have to remember that. Just run Terraform format and it'll actually do that for you. Okay. Now, If I run Terraform Init again, because remember, now we just introduced a remote backend storage for that, it's going to actually initialize, and I'll just go main big screen here, and it should detect, right? So it's like, hey, we detected a new backend. Do you want to migrate your previous local backend to this? And I say yes. So now I'm actually moving my state from my local TF state file and into Azure storage, okay? And if I run this command, so az storage blob list, you can see here now I have a brand new Terraform TF state file, which has just been created, okay? And if I click on the TF state here, you can see that this file has been emptied out. The backup is always here. Terraform just keeps a backup of this stuff, but now, I mean, it's actually safe to delete those two files. So now if I run a Terraform plan, it should call up to the Azure storage, get the Terraform state, and it should come back with there's no changes needed because your desired state meets the actual state that's in Azure. Okay. Okay. Before I jump to AVM, yeah, see, so found no differences, right? So we're good there. Okay. So now we have our Terraform all set up on our working machine. We have a resource group, and we actually have our remote state up in Azure storage, which is like perfect for what we need to do. Now, I promised you AKS cluster. We're going to get to that. But before we get to that, let's just make sure that we don't have a ton of questions backed up here. Okay. AKS fleet cross subscriptions. That's a great question. I think Terraform right now only supports a single subscription. That I would have to follow up on to see if there's any plans for that. You might want to check in the Azure RM provider repo to see if there's any outstanding issues for that. Oh my gosh, a human programming. Yeah. I'll show you Copilot programming later on. Let's see. This doesn't happen in any other. I'm not sure what that question is. Okay. How to optimize utilization of state file in multi-use account. I usually say to test everything on local machine and then use remote state only, even if planned. Haha. Okay. So what you could do is, yes, you can actually write the Terraform on your local machine and maybe even comment out the local state stuff, the remote state stuff. And then when you're ready to commit into your Git repo, you can do it that way. The other thing that you can do is I think you can use like Terraform environments. And Terraform environments actually lets you switch between different backend states. So you can actually do it that way. Let's see. Terraform. Let's just run that command. No, it's workspace. I'm sorry, not environment. So Terraform workspace is a way for you to kind of like have different versions or different environments. So you can create a workspace called dev, you can create a workspace called prod, and they can point to different Terraform remote states. Okay. All right. So we have everything ready for our AKS cluster. And if you recall, creating a Kubernetes cluster, and if you scroll down here, you can see all of the properties that are settable in AKS. AKS is a huge service and very configurable, and you can actually configure a lot of different things in here, right? And so this becomes really hard to look at, especially if you're just getting started with Terraform. A lot of times people just want to rely on modules, right? So it's a module is basically a Terraform configuration file that's packaged up in a way that is reusable for you or other teams. And so you can rely on this thing. Hold on a second. I thought I clicked that. Open in a new tab. Down here. So you can actually rely on modules to basically reuse code, leverage what's already been written, and then deploy that into your own environment, right? And so in the Terraform registry as well, do, 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 you can see browse modules. So Terraform registry has a ton of different modules for all these providers that are written by various folks. Anybody can publish a module here. All you need is a GitHub account, sign in, write your module, and then push it up to the Terraform registry. That's not a problem. What we will do here is we will actually use what's called the Azure Verified Modules repository. And that's loading up over here. And so Azure Verified Modules is written by folks at Microsoft that will basically put together these Terraform manifests and put them in a way that basically includes best practices, right? And the way this is broken up, and I'm going to tell you this in a second, there's modules for Bicep, and then there's also modules for Terraform. What you can do is you can look at the individual resource modules. So if you want to deploy an AKS cluster in a particular way, that with all the defaults that we would probably recommend, use the resource module. If you're looking at solutions, right? Oftentimes you want to deploy an AKS cluster with a container registry. This is where you would look at a pattern module, right? And then there are also utility modules, things like looking up Azure regions, little helper functions. Those are what's called utility modules. So if I click on this, you can see all the different resource modules. So there's container apps, API management. There should be container service here. The one thing that we are going to play with today is the AKS dev pattern module. And I only picked this because it's like one of the smallest modules that's pattern module available here. So let's go ahead and start to play with that. So to deploy a module, what you would need to do is, I can scroll back down to my main.tf file. All you need to do is now point to a module just by calling it a module, give it a name, an instance name, and then pointing to the source or wherever that repo is. Okay. And I can actually look this up. So if I click on this tab and it opens up over here in the Terraform registry. So again, these are all available on the Terraform registry. You can see here that there are provisioning instructions, and I literally just copied that and put it into the lab instructions here. And then it'll point you over to the actual GitHub repo. So if there are any changes, because remember, this is all open source. If there's anything that you see that should be changed, open a issue, submit a pull request. I mean, this is all community driven, so so it's always good to contribute back to help make it better for everybody, right? And so to use the module, source, version, and then the 3 required variables. What are these 3 required variables? Well, it's all documented here in the registry, so you can see inputs, okay? And you can see right here the required inputs. So it needs a location, it needs a name, and then a resource group name. I think we have all that, okay? So that's all you need. I mean, there's optional inputs, but we're not gonna input that for now. So what do we need? I'm just gonna copy this from the lab instructions. Dum, 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 dum. So I'll copy that, come back over here, and then I will replace that. So resource group name, we're actually gonna pull from the resource group that we just created. The location, we want us to deploy in the exact same location that we just created. And then the name of the cluster. Pay attention to the inputs documentation. It'll tell you that the name here is actually going to be used as a prefix or suffix of the actual name, but it should tell you there. So now that we've included a brand new module into our Terraform code, our Terraform needs to be made aware of that. And so I can run another Terraform init. It'll go back out to the registry, download the module, and now it knows everything about this module. And then we have cool things like syntax highlighting, IntelliSense, and even validation, right? So we'll download this module, and it's there. And I can do something like Terraform validate, and it says everything is good. We can actually deploy this, right? Tip here. I don't like typing Terraform all the time. And so I'll run an alias command and I'll just run TF, okay? This cluster actually takes a little bit to deploy. So I am going to do Terraform apply. I'm not going to do the plan and all that stuff like I did before. I'm just going to do apply. And Terraform always has you confirm that you want to do any apply action or any destroy action. This right here, the -- auto approve, I call this YOLO mode. Don't do this in production. This is actually gonna just bypass the whole confirmation altogether. But you know what? We're just doing a demo. We're trying to speed through this. So let's rock with this auto approve flag here. Okay. So now we have a module. The module is going to deploy an AKS cluster for us. And so you can see that it's going to deploy all these things. So there's going to be 9 things added. Okay. So we'll let that go. And we will take a look at what is left. Oh, I forgot this because I actually want the AKS name to be output. Okay. We can just add it here. And we'll run it again once this is complete, but we'll just kind of like let this do its thing here. This should take about roughly about 5. I don't know, maybe about 5-7 minutes to complete. Okay. So added the output, we did the init, and then we did the apply. Okay. So eventually this is all going to come back. And then once the cluster is created, we can then take the RG name and the AKS name, and we can run a command like this, Terraform output, and we can do a -raw on that. And we can basically pass that into the AZ AKS get credentials command, and we can then connect to the cluster, and then we can start working with the cluster, right? kubectl get nodes, and then we can deploy and do all the other fun stuff once the Kubernetes cluster is up and running. So we're getting to the end of the lab. It's not a very long lab. Let's talk a little bit about tips, tricks, best practices. I mean, I've been kind of sharing some best practices a little bit on the way. What I would say is Terraform, I use it all the time, and I use it to build demos all the time, just locally on my machine. But Terraform is infrastructure as code. And with all code, it should always be source controlled, okay? And so use something like Git to manage your Terraform configuration files. When I created this little working directory, I didn't initialize a Git repository, so I could do something like git init, right? And if you look at this here, source control, it's trying to add a bunch of stuff. I need to hide that. It's trying to add a bunch of stuff into my Terraform, or excuse me, is trying to add a bunch of stuff into my Git repository, it is always good practice to include this git ignore file. Okay. Let me find the link for that. What you should be doing is pop over to this little repo. I love this repo. It's like super handy. I'm going to post it in chat. It's basically a git ignore file for almost every single programming language that's out there. And so what you can do is you could run a curl command that looks like this. So I can just download the Terraform git ignore, and I can name it .git ignore in my root directory. And then now you see how the changes has whittled down from, I don't know what that number was before, but it's now down to 6. So it's going to ignore things like the .terraform directory, any TF state, because you never want to check in TF state into your source control repository. You want to handle that remotely somewhere else. So that's a good tip. The other thing that you should do is utilize modules, right? You want to keep everything dry meaning don't repeat yourself. So if you wrote something once, you want to be able to reuse that, right? Just I mean, kind of like the fundamentals of programming as well. If you want to create multiple resources of the same type, let's say you're deploying, I don't know, a virtual machine, and you want to deploy multiple virtual machines that all look and have the same attributes, use counters and loops. Okay. If you want to conditionally create resources, gets a little tricky with Terraform because there aren't really any, well, there is a Boolean way to do it, but you'd have to use a count for that, and I'll show you. I have an example of that. I have an example of that over here. I'm gonna load this up. So I have this AKS store demo application that I constantly work out of, and I have Terraform in there. So take a look at this AKS store demo repo. I will drop a link to this. I have a bunch of Terraform in here that you can actually use for reference. But basically, I'm actually terraforming a bunch of resources, but sometimes I don't want to deploy some of the observability tools. So what I would do is I would have a Boolean local variable, and you can actually, this is kind of like a Terraform trick here. You can actually use count. So based on the Boolean, you can say I want 1 or I want none, right? So this is one way to control the conditional deployment of resources. So that's just one little tip there as well. This is probably a whole can of worms if I dig into it right now, but you may run into a situation where you're the Terraform expert and you've inherited somebody's Azure resources that's not managed by Terraform. There's a lot of different ways to do it. I'll let you read through this here, but basically you can do Terraform import. You can use the import block. You can also use the import block to generate the configuration on its own. You can also do this, and I'll show you. This is really cool. If I go to resource groups, let's see. I'm just going to pick one of these. CNPG. This might be Postgres. Okay. Anyhow, just go to a resource group in Azure and then click down here under automation, right? There's export template. And you can see over here, you have a lot of different options now. You can actually export it into ARM, which is like the classic Azure. You can actually export it into Bicep or Terraform. And Terraform actually comes in 2 different flavors. There's the Azure RM, which we've been working with, and then Azure API, which I'll talk about right now. We only have a few minutes left on this stream. So definitely one way to do that. Now, when you want to deploy applications to your cluster, like AKS cluster comes up and you want to deploy like Helm packages or things like that. Well, Terraform actually has, like I said, it's plugin based. So if you hop over to the Terraform registry, there's a Kubernetes provider. There's also a Helm provider, right? So if you want to deploy Helm charts, you can do that. And I would say check out the repo over here for Kaito. I'm actually going to do a talk on Kaito in 2 weeks, and actually going to use this Terraform here. But take a look at this here. There's examples of how you can actually deploy the Kaito application into an AKS cluster. So we're actually going to do that in 2 weeks' time. So hope you tune in for that as well. Okay. Other tips, read the docs, right? The Terraform registry docs, like I said, is a gold mine of information. The other thing that you can be doing here is leveraging GitHub Copilot chat in agent mode and leveraging the MCP server for Terraform, because HashiCorp provides a MCP server for that. I just want to show you that because it is so cool. Hop on over to Copilot, open up your tools, make sure you have some of the built-in tools already checked, and install. I don't have it. You know, this is a good time to kind of show you MCP. There should be MCP Terraform. MCP server. If it's not here, hold on a second. I can kind of find it for you. Let's jump over here. So you want to use MCP servers in VS Code. Okay, so that's what you want to do. Add an MCP server. You know, there was a way that you can click. Hold on a second. Haha. This is the documentation that you want to use. So I'm just going to drop this into the chat window here. And it basically provides you a list of things that you want to do. Let me show you, because I'm in a different VS Code. I'm going to open this in my normal VS Code window. Did it open? Code. No. You know what I'll do? I'll do this. I will change my profile to my default profile. Aha. Okay. Sorry, everything is in the way here. And so once I'm here, I have that tool. I have MCP Terraform installed, so you can actually install that. And then look what I can do. If I just go back here, I'll copy this prompt, okay? And with this prompt, I basically want to say, I want to move away from this module and I want regular Terraform, okay? And so it says, I'd like to replace this module code in my main TF with the equivalent Azure RM resources. So this is moving away from modules and back to Azure RM, but I need help deploying the AKS cluster and container registry and linking the two, right? So you can actually submit that over to GitHub Copilot chat. And what this will do is it'll actually start calling the Terraform MCP server, which the Terraform MCP server is able to query its own docs. And then after a few runs, it will start generating the code file. I'm just going to say always allow in this session. Okay. So eventually what this is going to do is it's going to vibe code its way through recreating this Terraform. So there we have it. We have a demo of a non-human coding as well. Okay, so last bit here. I know I'm like a couple minutes over, but I do want to quickly talk about the AZ API provider. Okay. One big thing that I constantly hear about the Azure RM provider for Terraform is that sometimes a lot of the new resources just aren't available. One perfect example of that is AKS Automatic. AKS Automatic has been in preview for about a year, but because it's been in preview, there is no Azure RM provider for it. And so the only way for you to provision AKS automatic cluster is you have to use a different provider. And this different provider is actually called the AZ API provider, which is actually built by the engineering folks at Microsoft. And they basically have their own way of talking to the Azure RM API without necessarily using Azure RM. And the usage is pretty simple, I would say. So here is an example of how to deploy an AKS automatic cluster using the Azure API provider. So all you need to do is just basically include this thing called AZ API resource, give it an instance name, and then give it a type. Now, these are Azure RM types, right? So if you've done Bicep before, Azure, just ARM templates, that should look familiar. And so what you're doing here is, need to hide that. You give it a parent ID, and then this is actually a little bit dated code because you don't need a JSON encode anymore with the new version of AZ API. But basically, you just pass in all the properties for that particular resource. And then you can see that the code isn't terribly long. It's long because I'm configuring all the monitoring components with it. But you can see here that I'm deploying the AKS automatic SKU. And you should be able to just deploy that alongside your Azure RM resources. So you can actually use multiple providers at the same time. And if you want any of the documentation for the AZ API, if you head over to our Microsoft Docs for any of our resource templates, you can scroll down here. You can find AKS managed clusters, and you can see the different tabs, right? So we have Bicep, ARM, and Terraform. And so within here, this is kind of like the Terraform registry docs where we have all the properties documented. And you can see here, we don't need a JSON encode anything. So that example that I showed you was a little bit dated, but you don't need a JSON encode anything. You just set the properties as is. So that's really nice. So that's one way to work around the issue of not having all the latest and greatest features in Azure RM. So I highly recommend that you take a look at that. Let's see, before we go, how did we do on the actual resource deployment? So we have the resource group, and I'm just going to pop over to my Azure portal one time before we go and just make sure. So if I refresh here, and if I do example resource group, because this is what we've been working with. Come on, Azure portal. Might be quicker just to query using Azure CLI at this point. But the resources should be there, okay? I'm just gonna end it here because we are a little bit over time. I highly recommend that you guys go through this lab end to end and kind of like get familiar with the whole process. Once you know how to work with Terraform locally, put in a Git repo, push it up to your Git repo, share amongst your teams, and deploy it that way. So with that, I would say it's been very fun being back here. I would say what's next? Tune in 2 weeks time, August 19, same bat time, same bat channel. We are going to be playing with Kaito, the Kubernetes AI toolchain operator. We're going to be building RAG applications, and there will be a Terraform component in there, I promise. So yeah, it's been very fun to hang out with you here today. I will see you in 2 weeks, and thank you.
Thank you, everyone, for joining. Thank you, Paul, again. Our session is a part of a series. To register for future shows and to watch past episodes on demand, You can follow the link that's on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we'd love to hear what you have to say. You can find that link or on the screen or in the chat. Today's event code is 25632. And we will see you at the next one.